Okay, so carrying on from the previous video, we looked at moments. We're now going to be looking at the center of mass. So in the previous examples, we were looking at a uniform rod, and I've written out the assumptions for a uniform rod. It just means that the mass of the plank itself has a mass, right? And that mass acts in the middle of the plank. So that's what an assumption for uniform would mean. But sometimes in certain questions, they might say the rod is non-uniform, in which case we don't really know where the center of mass of the plank is going to be. So we can't say it's in the middle. It's going to be somewhere along the plank. We just don't know. And in this case, we have to actually find this new positioning of the center of mass. Right, so in this question here, we have a plank AB, which has a mass 24 kilograms and length 4.8 meters. A load of mass 15 kilograms is attached at C, where AC is 1.4 meters. The loaded plank is held in equilibrium. Remember, equilibrium means the resultant moment and the resultant force is equal to 0. And it's held by two vertical ropes at A and B. And the plank is modeled as a uniform rod. So in this case, in the beginning, it's a uniform rod, which means that the center of mass of 24 kilograms is in the middle of the plank. And the load as a particle and the ropes as light in extended strings. Find the tension in the rope attached at B. So in this first part A, right, it's exactly the same as what we did in the previous video, just doing moments about A, because we're going to work out the tension in B. So we're going to skip this part A for now. Right, carrying on, so the plank is now modeled as non-uniform. So in this case now it's non-uniform, which means that it's no longer in the center of the rod. With the new model, the tension in the rope attached at A is 25 newtons greater than tension in the rope attached at B. So first things first, let's go about drawing it. So we have two vertical ropes attached to the plank, and they're going to have each tension. So this is going to be TA and TB. This is going to be A and B. Okay, the position they have at C, there's a point mass, right, which is 15 kilograms. So that still remains there, and that's the distance of 1.4 meters away from A. And now they're asking us to find the distance of the center mass of the plank from A. So the center of mass, or the mass of the plank, is 24 kilograms, but we don't know where it's going to be. So let's say this is 24G, and let's label this distance X like this. So that's what we're trying to find. Right, additional information they've given us is that the tension in the rope attached at A is 25 newtons greater than the tension in the rope attached at B, which means that TA is going to be equal to TB plus 25. So this is an important condition that we're given just in order to find the tensions. Right, once we've drawn out the diagram, we can now just do what we did before, just do moments. And we're trying to find X, so it's the moments about A. Clockwise is positive. So we have the 15G times by the distance from to A, 1.4, plus this 24G, the mass of the plank, times by the distance X, which we're trying to find, minus TB times the distance of the whole plank itself is 4.8 meters. And that's equal to 0 because it's still going to be in equilibrium. As you can see, there's two unknowns, right? There's this TB unknown here, and there's also this X value unknown here. So we need to find one of these values first in order to find the X value. Luckily, we're given that TA is equal to TB plus 25, right? So what we can do now is resolve vertically. So if we were to resolve in a vertical direction, we'll have TA upwards plus TB upwards minus the 15G downwards minus the 24G downwards as well. And that's equal to 0 because it's still in equilibrium. Right, so we want to replace this TB. So we want to find what TB is equal to. And you can see here, TB is equal to TA minus, TA is equal to TB plus 25, which I can substitute into this TA position here. So I'll get that TB plus 25 plus TB minus 15G minus 24G is equal to 0, like this. Now just rearranging, right? So we have, what do we have? 2TB is equal to 39G minus 25. So TB is equal to 39G minus 25 all over 2. Once we found TB, I can substitute this TB back into this original moments equation, right? That way we're only left with one unknown, our X. And if we were to substitute and calculate for X, you get the value of X is equal to 2.77 meters, like so. So you can see here the concept is still the same. The fact that we're doing moments about a certain point, a certain pivot, and we're resolving vertically because we know it is in equilibrium. It's just the fact that the center of mass is no longer in the middle because it's non-uniform, and we have to find this new positioning of the center of mass. Let's try another question here. So we have a seesaw in a playground consists of a beam AB, length 10 meters, supported by a smooth pivot at the center C. Sophia has a mass of 30 kilograms, Roshan has a mass of 50 kilograms, and sits at a distance of X meters. The beam is initially modeled as a uniform rod, meaning the center of mass is in the middle, right? So we're going to skip part A for now because that's to do with center of mass. For B, state what is implied by the modeling assumption that the beam is uniform. Well, if it's uniform, we know that the center of mass is in the middle of the beam. Right. Roshan finds that he must sit at a distance of 4 meters from C for the seesaw to rest horizontally in equilibrium. The beam is now modeled as a non-uniform rod of mass 25 kilograms. Using this model, find the distance of center of mass from C. Right, so let's draw this diagram first. So we have a rod pivoted in the middle at C. Sophia still stands at A here, and she has a mass of 30 kilograms, it's 30 G here. They say that Roshan now has to sit at a distance of 4 meters from C, so in this position here, he weighs 50 G, and this is going to be 4 meters. And Sophia is a distance of 5 meters away, because the whole plank is 10 meters. And they say now the mass is a non-uniform rod, and the mass of the plank is 25 kilograms. And so we need to find out where that's going to be. So we can write out a positioning here, so roughly here, like this, and we're trying to find this distance x here. Right, first things first, I put this 25 kilograms to the left of C, okay? And sometimes you might wonder, well, why can't it be to the right of C? Well, the reason why it can't be to the right of C is if I was to disregard this 25 kilograms here and just do moments now, right? So let's just do moments now straight away. So moments about C going clockwise. So we have 50 G times 4, and then we have minus 5 times 30 G, which will give me 200 minus, so it's be 50 G Newton meters, and that's going to be in a clockwise direction. What does this mean? Well, it's actually going to be rotating in this direction here, which means that it's no longer in equilibrium. So in order for it to be in equilibrium, there must be an additional moment which acts anti-clockwise, right? That way it will cancel each other out because we want it to be 0. If it's to be anti-clockwise, then this 25G has to be to the left-hand side of C. It can't be to the right-hand side, because if it's the right-hand side, it will act clockwise. So that's why I have to put this 25G to the left-hand side. This kind of stuff you need to be very well aware of, because the positioning of the center of mass of the plank is very, very important. If you were to put it on the right, then you get an incorrect answer. So just be aware of this. Anyway, now we've done the drawing. Now we can actually do moments about C. So moments about C here. As you can see here, it's going to be the same equation here, right? So these parts are going to be the same. So it's going to be 50G times 4 minus 5 times 30G. But now we have an additional moment caused by the 25G, and that's going to act anti-clockwise. It's going to be negative 25G times the distance x, which is equal to 0, like this. And then all you have to do now is we have 25Gx is equal to 50G. Therefore, x is going to be 2 meters away from C to just to the left of C. So as long as you clearly understand the question and the positioning of every single position, then applying the moments is the same method as we've been doing all this time.